3 different side lengths. Yesterday, the 2 legs were the same length. So that made it fairly easy because we know 2 of them are the same, the third one was different. Today, all 3 sides are going to be different. And we're going to give you different combinations. So I might give you the short leg. And then I can find the other 2 pretty easy. Sometimes I'm going to give you the long leg. Sometimes I'll give you the hypotenuse. So we're going to usually be given one side. We have to look and see what side is it that we're given, how we're going to use that to find the other 2. And that's going to be typically our goal, is to find the other 2 sides. All right, so kind of like yesterday, same basic idea. We're going to take this triangle and we're going to place it just like this one looks. Now, I know this one doesn't have a 30-degree angle in it, but that's because I have a 90 and a 60 already. So this third angle has to be 30, even though it's not labeled as 30. And so we're going to throw this up here. I'm going to label this as K radical 3, K, and 2K. And if you wanted to put 30 in here, you could, just to know where the 30 is at if you need to. Probably should figure it out on your own pretty easily, but if not, you can put it in there. Okay, so we know that K is 5. And this is the one we just did up above. So that means that Y is 10. X is the same as K radical 3, and we know that K is really 5, so this would become 5 radical 3. So X is 5 radical 3, Y is 10. And that would be our answer. Okay. Kind of like yesterday, there's not a lot of work involved here, right? We're not doing a whole lot of math. We're not solving equations, really. And for most of these, we're really just using the expressions to find the other 2. Okay, same thing here. And I'm not going to do this on every single question today. But just so you kind of get the hang of this, we want to match up. Obviously, here's the 90. Make sure the 30 is down here. And then look at the 3 sides that we have. So once again, the side that we are given is K. This would be K radical 3. This would be 2K. So on this one, we know that K is 14. That number is going to change over and over again, right? So then Y would be 14 radical 3. The hypotenuse would be 14 times 2, which is 28. If I'm given the short leg, it's usually pretty simple, pretty straightforward. If I'm given the hypotenuse, it's usually not too bad. On this one here, okay, once again, we throw it up there just to match up how it looks. 32 is going to be the 2K side. This would be my K. This would be my K radical 3. Okay, so here's what we're going to have to do. This time we don't know the value of K, but we can find it pretty quickly, right? 2K equals 32. So K would be 16. And that would be this side right here. So X is 16, which is also K. X and K are the same thing in this case. K is just what I'm going to label every single triangle with. So if I know that K is 16, then what would be the length of this side right here?
16 square root of 3.
16 square root of 3. So Y is going to be 16 square root 3. And that's our answer. Okay, same thing here. This is 2K. This is K radical 3. And this is K. You don't necessarily have to write out the equation like I did here. You just have to know this is double. So if I take 46 and divide it by 2, that gives me the short leg, which is 23. And that's my Y value. So then x would be 23 radical 3. Okay. So we've talked about knowing the short leg. We've talked about knowing the hypotenuse. Those are both kind of our go-tos as being fairly simple or straightforward. There wasn't a whole lot of work involved. And this one here is not too bad. If we labeled everything, here's my k, here's my k radical 3, here's my 2k. Hey, and we had a couple of problems like this yesterday. Yesterday it was a radical 2, today is a radical 3. But if this is 9 radical 3 and k radical 3 is this expression, what's the value of k got to be here? How much? 9, yeah. So we know that k is 9, so that means x is 9. This side right here is 9. X and k are the same thing. So this would be 9. How do I get my hypotenuse? If k is 9, what are we going to have to do with it? Multiply it by 2. Yep, just take it times 2. And that would be it. Okay. Still not too bad, right? Still not a lot of work involved there. Same thing here. This is k radical 3. This is k, and this is 2k. Just make sure you label all of them correctly. That's where this all comes into play, right? If you have everything written on both sides, it doesn't matter how this triangle is drawn. I should get this to match up with any picture that I have, no matter what. Once again here, we know that k is 15 because this is 15 radical 3, so k is 15, which is the same as x, and then y would be 2 times 15, which is 30. Just kind of understanding the pattern is where it all comes in. Once we get that first one labeled, then it gets to be a little bit easier after that. Okay, on this one here, here's where it starts getting a little bit more difficult. Okay, so we have k radical 3, and 2k. Here's the part that's a little bit tricky here is 6 is the length of this side. It's not 6 radical 3, it's just 6. Okay? And so what I have to do here, I have to find out good morning. Thank you. I have to find out what the value of k is. We had some problems like this yesterday. The ones we had yesterday all had a radical 2 here. But if I wanted to get k by itself here, what am I going to have to do to get k by itself? Divide by radical 3. And what we said yesterday was we don't want to leave a radical on bottom, ever, right? So we got to get rid of the radical off the bottom. How do we get rid of the radical off the bottom? Multiply by that exact same radical. And I got to do it to both top and bottom to keep it an equivalent fraction. So that gives me 6 radical 3 over 3. Out of these numbers, which numbers can I simplify?
6 and 3.
The 6 and 3. Can I simplify these 3's? No, because this one's under the radical, right? So only the 6 and the 3 can be simplified, and that would become 2 radical 3. So that would be y. Okay, to get x, we're going to double this expression. We're going to double 2 radical 3. So if I take 2 radical 3 times 2, what do you think that might give me? Two radical 3 times 2. 4 radical 3. We cannot multiply Some people want to think this is distributed property. This is not the distributed property, guys. There's no plus or minuses going on here. The 2 does not have to distribute to everything in here, okay? 2 times 2 is 4. I cannot take 2 times 3 because 3 is under the radical, okay? So that's probably the biggest mistakes that are made. People try to take the 2 and multiply it by things they shouldn't be multiplying it by. Only multiply it by the number that's on the outside. Kind of the same thing here. The only number I could reduce was the 6 and the 3 because they're outside the radical, right? And so that's where you got to be careful on that one. Okay, the middle one. This is kind of a weird one. This time, k radical 3 equals 20. We're going to go through the same process we just did. And so you might say, well, what's so weird about this one? Well, here's what happens. I'm doing the same work that I just did. I'm dividing by radical 3. And then I'm going to multiply by radical 3 on top and bottom. And I end up getting 20 radical 3 over 3. Very similar to what we just did here, right? Can I reduce 20 over 3? No. Okay? So then you might think, well, what can I do? And you actually can't do anything. Okay? You cannot simplify this. You can't simplify the 3's. So this right here is my k value, which is y. So y equals 20 radical 3 over 3. If I were to take 2 times 20 radical 3 over 3. Think about multiplying by fractions. Let's do a really easy one. Let's say I take 2 times 4/9. Let's not even put a radical in there. If I take 2 times 4/9, what do you think that's going to give me? Maybe want to take a shot at that one? 2 times 4/9. What would that make? 8/9, right? Do not multiply the 2 by the 9 because this is assumed to be like 2 over 1. And when I multiply fractions, I'm just multiplying straight across, okay? So this would become 8 over 9. So when I do it down here, 2 times 20 radical 3 over 3, the only thing the 2 is going to be multiplied by is the 20, okay? And so then that would be 40 radical 3 over 3. It doesn't really look simplified. That's what makes it kind of look a little bit messy because we want to try to simplify it more, but we really can't. That is as simplified as we can possibly get for that fraction. Can't do any more with it. And that's how we're going to be expressing our answer in simplest form as much as we can. Okay, try this one on your own. This is k, this is k radical 3, this is 2k. See if you can come up with this one. Use the pattern that we've done the last 2 times. See if you can come up. This one's a little bit easier than the one we just did. I'll do it as you guys do it and see if we come up with the same thing. Okay, the first thing we probably want to find is x, or k. K radical 3 equals 9. That's the one we know. Anybody think they got x? Anybody want to take a shot at that one? Hannah?
3 radical 3.
3 radical 3. Everybody agree with that? Okay. And then y would be?
6 radical 3.
6 radical 3. Yep, that's exactly right. Okay. Here's how we get there. We set k radical 3 equal to 9. We divide it by radical 3, multiply by radical 3 top and bottom. We simplify it, and that gives us our k value, which is the same as x. Okay? And then the hypotenuse is just double that. Okay, questions on that one? When we're given this side, when we're given the k radical 3 side with a whole number, that's the one that's the hardest by far. Some of these are really easy. Some of them are a little bit harder based on what we're given. Okay? So they're not all going to be the same necessarily. Okay, this one here, the side length that I'm given is radical 3, but it is my k side. So this would be k radical 3, and this would be 2k. Okay, so first up, we're going to take, this is my k value right here, okay? And if I doubled it, if I take radical 3 times 2, or 2 times radical 3, however you want to think of it, what's going to happen there? What would that give me? 2 radical 3, exactly. You cannot do anything with it. We're just going to take 2 times radical 3, and that's it, 2 radical 3. You cannot multiply the 2 and the 3 together because 3 is under the radical, okay? It's a big deal. This one is saying we're going to take whatever k is times radical 3. Well, here what we're saying is that k is radical 3. So I'm going to put radical 3 in for k, and if I take radical 3 times radical 3, what's it give me?
3.
3. X is 3. And that's my answer. Some of your answers will have a radical on them, some of them won't. Okay? It just depends on the numbers that we're given. Okay, this problem's a little bit different. Okay, they're going to give you some different variations of some of these. And so we're throwing this out there because you're probably going to see one like this at some point in time. The bottom here is split, right? But what is the length of the bottom of that triangle? It's 4, right? 2 and 2. So what kind of triangle do we start with? Equilateral, right? This is an equilateral triangle. They drew in the hypotenuse, or the altitude, I should say. If I were to redraw this, because we said that this was equilateral, didn't turn out very good. Should be 60 and 60. Zoom in a little bit here. So my 60-degree angle is going to be down here. This is going to be a 30-degree angle. We know this is 2. This is what we're looking for. And this is 4. Okay? And so this would be my k. This would be my 2k. So h is really the k radical 3 side. So the length of h is 2 radical 3. Okay? No decimals today. Don't go to decimals. The only time we would go to decimals is if we're doing a story problem, okay, and we're trying to find the height or length of something. Okay, this one here. Find the area of an equilateral triangle and the square. So the first one here. If I were to redraw this triangle, here's my 60, here's my 30. This is 4 radical 15. Okay, 4 radical 15 is really my k radical 3 side, right? Here's my 60-degree angle. This is the side across from 60, so that's my k radical 3 side. So I'm going to do k radical 3 equals 4 radical 15. I'm going to divide by radical 3. And I get 4 radical 5. Okay, that is this piece right here. So if that piece is 4 radical 5, then the piece over here is also 4 radical 5. Okay, so here's some more rules of things and how we can combine them. Think about if this was 4x and 4x, when I combine them together, I get 8x, right? If this is 4 radical 5 plus 4 radical 5, what would be the length of the entire bottom? 8 radical 5. We cannot add the 5's together. Those are my like expressions. Kind of like if I added 4x and 4x, I get 8x, right? I don't do anything to the x's. If I add 4 radical 5 and 4 radical 5 together, I would get 8 radical 5. The other day we talked about the area of a triangle, and we said the area of a triangle is base times height divided by 2. We just found the base, which is the bottom side. We already knew the height, divided by 2. Okay. So now if we multiply these two together, 8 times 4 is 32. Radical 15 times radical 5 would be 15 times 5, 75, all over 2. Okay, and we're trying to write our answer in simplest form. So first thing I can do is I can reduce the 16, or reduce 32 and 2 to become 16. Okay. Now I got to reduce the 75, or simplify the 75. And when I simplify radical, what we're looking for is we're looking for pairs, right? So when I look for pairs here, what's something that goes into 75? 5 and 15, right? We just did it. You could also do 25 and 3 if you wanted to. There's lots of things that go in there. Okay, so I'm going to write this out, and here's what it's going to look like. 3 times 5 times 5. That's my prime factorization, right? But when I look at the prime factorization here, what do I have pairs of? 5's. So whatever I have a pair of, I'm going to move out here. When I move it outside, I've had a lot of people ask me this question: what happens if I already have a number on the outside? Then we're going to multiply those two together. I'm going to take 16 times 5. And so this would become 80 radical 3. And that would be our answer. Okay. We just have to make sure that we simplify our radical or fraction as much as we possibly can. Okay, this one over here. We have a square. Now this one we got to be a little bit careful on, okay? We're going to throw you a little bit of a curveball here. If we have a square, if I were to draw, and it doesn't matter which triangle I draw, what would be the measure of these two angles right here? They'd be 45s, right? Because these two sides are the same. This is what we talked about yesterday. These two sides are the same, so these two angles must be the same. So there's the curveball right there. Now you're going to start to see any of the special triangles that we've had. So it won't necessarily just be 30, 60, 90s. Fantastic news, right? We know that this is 28. So what we're using here is this guy, right? The blue one. And then this would be A, and A radical 2. So we're going to set a radical 2 equal to 28. To get a by itself, we're going to divide by radical 2. And then I'm going to multiply by radical 2 on top and bottom, which is 28 radical 2 over 2, which is 14 radical 2. How do we find the area of a square? We just did a triangle. How do I find the area of a square? Length times width, okay? In this case, the length and width are exactly the same thing. So we're going to take 14 radical 2, which is my length, times 14 radical 2, which is my width. Length times width. If we multiply these two together, I can multiply the two 14s together. 14 times 14 makes 196. Radical 2 times radical 2 is really radical 4, but the square root of 4 is really 2. So this is really 196 times 2, which is 392. You do not have to have a radical in your answer. Okay? We go from having radicals in the entire problem, and all of a sudden, now we don't have a radical in my answer. That kind of throws people off. They think they did something wrong. That's going to happen from time to time, where we don't necessarily have a radical in our answer.
I noticed that you can also get 392 by doing 28 squared and then dividing that by 2. Is that true for all squares?
Yes, because it's a square. Yeah. Okay. This one here, estimate. So anytime you see words like this, estimate means our answer doesn't have to be exact. So that's a good thing. My answer can just be a decimal here. This is an equilateral triangle. And so when we have an equilateral triangle, it'd be very similar to what we just talked about. If you wanted to, you could draw the triangle out here. This angle down here is 60. So this would be 60, 90, and a 30. Okay, here's where you got to be careful. The base is 36. So we're going to do base times height divided by 2 because it's a triangle. My base is 36. We don't know the height. But when I split this thing up right here, when I split this sign up, it's going to be 18 on either side. And that would mean this would be 18 radical 3. And that would be my height. So that's what's going to go over here. Okay, and you got a couple of options here. You can simplify it all and then put it into the calculator, or you can just type it in as you go. And that's probably what I would do here. So if you have a calculator, let's get out. Let's try putting this into your calculator, because here we're writing our answer as a decimal. So I want to make sure you know how to type this in. Everybody's calculator is going to be slightly different here. So 36 times 18 times the square root of 3. And once you get all of that, make sure you hit equals and then divide by 2. Okay, anybody got it?
About 561.2 inches.
Okay. It doesn't tell us what to round here to, so let's just nearest inch would be good, or nearest tenth of an inch would be good. So about 561.2. Okay, anybody need help with their calculator on that? Everybody able to get 561.2? Okay, so that's really the only difference here is we're still doing all the work the same, but because we're doing a story problem, then we wouldn't probably write our answer in radical form, right? That wouldn't make a whole lot of sense. So we're going to actually get a number out of that. Okay, I'm gonna jump down to, let's see here. Let's do this one and then we'll call it good, okay? We're basically doing two problems in the same problem here. Okay, so the angle that the truck is going up. So what it's telling me here is that the horizontal distance here is 80. If the truck was just to go straight ahead, he would be driving 80 feet. Okay? If the ramp comes up at an angle of 30 degrees, okay, I put the 80 in the wrong spot though. That's my fault. Because the ramp is going to be moving up. So actually this would be my 80. That's my fault. I read it wrong. 80-foot ramp, which means the ramp is what he's driving up. Okay, so what would this, in a 30, 60, 90 triangle, what would that piece right there be? It'd be 40, right? That would be my K value. So it wants to know how high is the 80-foot ramp up. In this case, it would be 40 feet off the ground. If I redraw this triangle, because now it wants to know what happens if it's a 45-degree angle. So now if the angle's a little bit steeper, this is going to be 80 again. This is my A radical 2 side, and this is A. So I'm going to say A radical 2 equals 80. Because we're doing a story problem here, we don't have to put it in simplest radical form. So all we're going to do here is take 80 and divide it by radical 2, and we can punch that right into our calculator. So try putting that one in. 80 divided by radical 2. Okay, and then what would that be as a decimal? Okay. Yep, about 57, depending on what we're rounding to, about 57 feet. Okay, so if I had a 45-degree angle, that truck's going to be higher up in the air, right? So the higher the angle, then the higher up the truck's going to be. Okay. You would go 80 divided by square root. Okay, I'm going to go get your assignment up here for you. I don't think I have it up yet, so I'll get that loaded for you. I'm going to post the answers to the 45, 45, 90 worksheet tonight. So if you need that, or if you want to check that, I'll have those up over the weekend for you. The homework assignment today is going to have some of both problems on it. It's going to have some 45, 45, 90s. It's going to have some 30, 60, 90s. So make sure you look at the triangle carefully. All of your big ideas will be due on Tuesday, so make sure you get all your big ideas. That's something else that you can do on Monday when I'm gone.